Freiburg, Germany, is often seen as one of Europe's greenest and most sustainable cities. Back in 2017, the city opened up its new town hall, called Rathaus am Stühlinger. What makes this building special is that it doesn't just save energy, it actually produces more than it uses. In fact, it generates extra renewable energy and feeds it back into the grid. Buildings like this are called net plus energy buildings, meaning they go beyond the idea of net zero. They create more energy than they consume throughout the year. But how? By combining two powerful natural resources, sunlight and groundwater. Its building-integrated photovoltaic facade captures light from above, and its ground source heat pump system harvests stable temperatures below. Together, they form a continuous energy loop, one that keeps the building powered, heated, and cooled with almost no fossil fuels. Let's start with the facade, the building's solar skin. Instead of just mounting panels on top of the roof, the architects turned the entire facade into an energy generator. These are called Building Integrated Photovoltaic Panels, or BIPV. They replace conventional cladding materials, becoming part of the structure itself. Each panel contains layers of silicon solar cells sandwiched between glass sheets. When sunlight hits these cells, photons knock electrons loose inside the silicon. This creates an electric current, direct current, or DC, which is collected to thin metallic conductors. That current is sent to inverters, which convert it into alternating current, or AC, usable by the building's electrical system. In Freiburg's town hall, the panels are both vertical and horizontal. Roof-mounted PV, 461 kilowatts peak capacity. Facade-integrated PV, 221 kilowatts peak capacity. In total, that's 682 kilowatts peak, enough to generate around 550 megawatt hours per year. But these panels do more than just make electricity. Because they're built into the facade, they also act as permanent shading devices. The vertical BIPV fins are placed outside the windows. During summer, they block high-angle sun to prevent glare and overheating. During winter, when the sun sits lower, light passes underneath the fins to naturally warm the interior. This design reduces the building's cooling demand. So while the panels produce electricity, they also save energy by lowering indoor heat loads. Electricity from the BIPV panels is first used inside the building to run lights, computers, and most importantly, the cooling and heating system. When production exceeds consumption, excess electricity flows back into Freiburg's city grid. When the sun sets, the building can draw small amounts back as needed. This daily exchange allows the town hall to operate almost entirely on self-generated solar power. By day, it's powered by sunlight while also storing energy. By night, the extra electricity stored during the day can also be used to supply the building. Now, let's move underground. Below the town hall, a system of wells and pipes connects the building to the natural thermal energy of the earth. Just a few meters down, the ground maintains a steady temperature, roughly 10 to 12 degrees Celsius all year round. The system uses groundwater-coupled heat pumps, each acting as a thermal engine that moves heat between the earth and the building. Here's how it works. In winter, the pump extracts heat from groundwater. That water passes through a heat exchanger inside the heat pump. A refrigerant fluid absorbs the heat and evaporates into gas. This gas is then compressed, raising its temperature. The heat is transferred into water circuits that flow through thermally activated concrete slabs and radiant ceilings, gently warming the spaces above. In summer, the process reverses. The pumps remove heat from the building and send it back to underground. When outside temperatures are mild, the system can even bypass the compressor entirely, circulating cool groundwater directly for free cooling. This method uses the low energy principle, working with small temperature differences to minimize energy waste. For heating, supply water only needs to reach about 28 to 35 degrees Celsius. For cooling, just 15 to 18 degrees Celsius is enough. Because the heat pump isn't fighting extreme temperatures, its seasonal performance factor, or SPF, reaches up to 4.6. That means it produces more than 4 times the heat energy compared to electrical energy it consumes. The town hall slabs act as thermal batteries, thick concrete floors that store heat or coolness for hours. The control system even uses weather forecasts to pre-charge the slabs at night, so the interior stays stable through the changing conditions with minimal energy input. Together, this system provides year-round comfort with up to 78% less energy than conventional HVAC setups. Now, let's connect the dots. The building's two main systems, the solar skin and the geothermal heat, work in perfect synergy. During the day, BIPV panels generate electricity that powers the heat pumps. The heat pumps, in return, use the electricity to heat or cool the building using groundwater. Because the panels produce the most power when the building is most active, the system achieves a natural balance between supply and demand. Whenever solar generation exceeds usage, the surplus electricity is fed back into the public grid, offsetting the small amount of power the building imports into darker months. At the end of a full year, the numbers speak for themselves. Total energy consumption, 1,402 megawatt hours. Solar energy produced, 1,385 megawatt hours. That's a difference of just 1%, effectively net zero. If the backup boiler were powered by biogas instead of natural gas, the town hall would actually be net positive, producing more energy than it consumes. Freiburg's new town hall proves that net zero design works when buildings and nature function as one. Its facades capture light, turning it into electricity, while its foundations breathe with the earth, exchanging heat instead of burning fuel. Together, they create a closed, renewable energy loop, where sunlight powers the building and the ground stores its comfort. Malaysia can do the same. With our tropical climate, abundant sun, and natural airflow, we have every advantage to build smarter. By using passive cooling, solar power, and local materials, our buildings can produce energy instead of consuming it. Freiburg shows what's possible. Now, it's our turn to adapt, innovate, and build a truly sustainable Malaysia. Blech.